Problem 82, we need to switch these equations into graphing form and then figure out some stuff once we have them in graphing form. So how we're going to switch them into graphing form is to do completing the square. So if I take a look at this first equation here, I have y equals 3x squared minus 18x plus 26. So to switch into graphing form, I need to first divide the 3, my a value, out of both of those. So I'm going to factor a 3 out and end up getting 3 times quantity x squared minus 6x. My 26 still stays on the outside, though. I do not do anything with the 26 rather. I am now going to complete the square with the quantity that's inside the parentheses. So in order to do that, I'm going to take this value right here, negative 6. I'm going to divide it by 2, which gives me negative 3. And then I'm going to square that. So negative 3 quantity squared is going to be a positive 9. That is going to make that set of parentheses a perfect square. So 3 times x squared minus 6x plus 9. And the 26 stays on the outside. This right here is now a square that has an x squared and 1, 2, 3 x's, so it's x minus 3. You have 1, 2, 3, negative 3 x's there, so an x minus 3 on that side, and there's my positive 9. However, what I did not do to this problem is I did not just add 9 to this problem. The fact that I have a 3 on the outside here, I need to now distribute that to the 9. So, I am going to subtract away here 3 times 9. It's the value that I have right here in my completed square. Same value that's right there. So my final answer then is going to be y equals 3 times my square now has side lengths of x minus 3 squared, and then 26 minus 3 times 9 is going to be negative 1. That is now in graphing form. So I don't need to graph that. I can identify the vertex. The vertex then of this problem is going to be at positive 3, negative 1. And my axis of symmetry is going to be going through my x value of the vertex. So it is x equals 3. For problem B, I'm going to do the same thing. It's just going to be a little bit more difficult because of the fact that when I divide the 3 from here, I do not get a b value that works out nicely. It turns into a fraction. So I'm going to factor that 3 out. So I'm going to have y equals 3 times x squared minus 4/3 x. And my 11 still stays on the outside. So I take my negative 4/3 and I divide it by 2, so my 2 goes in the denominator. That gives me a negative 4/6. When I square a negative 4/6, that's going to give me a positive 16/36. So we're dealing with a lot of fractions here. However, the process is still the same. So now I am adding, to complete my square, 16/36. My negative 11 stays on the outside, but now again, this number here is being distributed to the 3. So what I need to subtract away now, minus 3 times 16/36. Again, it's the number here times the number 3 that is being distributed to it. So now, my next step here is going to be 3 times my perfect square. My square is going to have side lengths of negative 4/6. So I have x squared minus 4/6 oops, not an x squared. It's x minus a 4/6, squared. There we go. That is now my perfect square. And then I am subtracting away 11 minus, and if I simplify this right here, that is actually going to become 4/3. It's going to reduce down to 4/3. The reason why that's going to reduce down to 4/3, I can take the 3 and the 36 and reduce that down to 1/12. And then 16/12, I can divide those both by 4, and that'll be a 4/3. So my last step now is just combining the like terms. I have 3 times x minus, I'm also going to take this 4/6 here and reduce that. That is a 2/3 squared minus, getting a common denominator to subtract them, is 37/3. So my vertex for this problem is at a positive 2/3 and a negative 37/3. My axis of symmetry is going to be x equals 2/3.